Okay, so hey everyone, I'm Nick. I'm going to give a talk about animation stuff again. Yeah, as you might have seen at last Emberfest, so I'm Nick Schot. I'm working for Simplabs currently. Have a lot of hobbies. As you can see, this isn't even half of them, I think. Coffee, model trains, microcontrollers, animations on microcontrollers. And yeah, so basically I want to walk through a bunch of animation stuff, and we're gonna start with the basics, basically. I'm gonna sit down for this one because there's gonna be mostly demos with some live coding, and this table isn't very tall. So basically the most basic type of animation technology you can use on the web are CSS transitions and animations. With CSS transitions, you basically define transitions for state changes of like classes or a pseudo selector like a hover. And with a transition, you can let the CSS animate between them. A keyframe animation is a little different, and we will see that in the demo next up. Generally, these kinds of animations provide limited control, but they're very robust, because the browser basically handles everything for you. And they also tend to be quite performant. So let's see what that looks like. Here we have a simple button with some styles. I will need to zoom in a bit, probably. Basically, we have the button with the hover state where we modify the border radius and the background color. Right now, that looks like this. Also, one note, these animations, all of them, will probably not look great for the people on Zoom, because Zoom is not very good at showing 60 frames per second frame caps. But I assure you it looks fine on my screen at least. So yeah, let's define a transition for this button. Basically, all we need to do is use the transition property, and we're gonna transition everything, and we can specify duration. This is like the simplest form, basically. This is 3 seconds. So now when we hover over our button, it will basically transition between the two states that we defined. There is already kind of a side effect that is a common pitfall. As we are animating everything, if you, for example, make your screen big, this is definitely one to remember. This one is way too common, and you can quite easily solve that by actually stating what properties you want to animate. So in this case, what are we animating? Like the border radius. And then we can specify the background as well. It's just, all of the background is probably safe. Yeah, and now we'll see that our button is just immediately resized. Yeah, so now an example that's a little more complicated, and that's a modal. I've created a very simple modal component here, not using the fancy new dialog component yet that browsers support since 2 weeks. It's just a bunch of divs. We have like a container wrapper, a backdrop for the modal, and the modal itself with its contents. I will zoom in a bit again. And there's a button to open the modal and a normal like if statement, like a handlebars if statement. And if we open this modal, it looks like this. I will zoom in a bit here too. We can close it again. No animations here. So basically, we can't really easily animate this model with the CSS transition that we use for the button right now, because there's not really a starting state, because the if statement fully removes the elements from the DOM, right? What we can do, however, is use a CSS animation with keyframes, because that is triggered as the element is inserted as well. So here I already defined them, like there's a keyframe animation here, for the fade in of the backdrop, and the keyframe it can be as simple as a from and a to. You can also do percentages if you want to specify more. In this case, we're going to fade in from 0 to 1 for the backdrop, and we want our modal to fly in from the top. So we have keyframes to translate the modal to be right outside our screen, and then translate it to 0, which is basically this position where it's now, its natural position in the DOM. Yeah, and I've already put some code here to enable these animations. I'll make them last 3 seconds again so that the Zoom people don't see just 2 frames. This is, of course, way slower than you would want any animation to be. Like, they need to be snappy, they don't need to get in the way. But as we can see now, our modal animates. Yeah, very, very nice text. Very useful modal. But now if we close it, we run into another problem. We can animate the entering state, but our modal is immediately unrendered as soon as we click the close button, because in the template, show modal will be false, and Ember immediately unrenders all of this. So there's an Ember add-on called Ember CSS Transitions, which kind of provides a solution for this. We have the same modal here, and in this case, we've defined what the modifier that the Ember CSS Transitions provides with some class names. And what Ember CSS Transitions allows us to do is specify 3 states, basically. Like a starting state, a final state. So we go from opacity 0 to 1 for the backdrop again. And then a transition for while the animation is happening. This is technically somewhat similar to what we did just before with the keyframe animation, except under the hood it works slightly differently, in that in order for this animation to work, the opacity 0 class needs to be applied just slightly after the modal initially renders for the browser to pick up the transition. Let's see. So if we open it, it basically looks the same. But what Ember CSS Transitions does under the hood is, as soon as we click close, is clone all the contents that are within the if statement with the CSS transition modifier on there, and put them on a parent element that is outside of the if statement, basically. And that allows us to also have a closing animation. One thing this does not support, however, is interruptions, as you can see, because it's gone again. I'll just do it again, just so you can see. And that's when we basically get onto the next type of animation technology. And the most common one today is based on a browser API called Request Animation Frame, which basically allows you to sync code to whenever the browser is going to render the next frame. And with this API, you get basically complete control over all of your animations, which is very useful for complex situations, like the interruption we just saw, or if you're animating between routes even. And what most of these animation frameworks do is that they calculate where elements need to be right before every frame renders. So basically, while the animation is running, every, what would it be at 60 FPS, 16.67 milliseconds, it's gonna see what time it is, do a calculation, apply inline styles, etc. So this all happens in JavaScript, and we do direct DOM manipulation. And that means it might be affected by other running code. So if you're, for example, doing a page transition while also doing some kind of API request, which requires a lot of processing, your animation may start to stutter. Let's see. Oh yeah, so let's first look at this modal demo again, but now we've implemented with Ember Animated. It looks mostly similar again, except it's organized a little differently. Ember Animated provides us with some constructs to allow Ember Animated to intercept the rendering, so that it can measure the element before it changes. and that's why we need to use this animated if construct. But otherwise, it's roughly the same, and we have a transition definition here. We have the same for our modal. And yeah, here is the actual animation definition in JavaScript. I wouldn't really look too much at this. So basically what we're doing here is for any sprite that is inserted, in this case our modal, we tell it where to start the animation. So this is basically the same as the CSS animation. And then we tell it to move the sprite to its final position. And the same happens for removed sprites and kept sprites. I will get back to the kept sprite situation later. But a removed sprite is basically the modal as it unrenders again. So if we look at this demo, we now have a modal that flies in and out again. And we can also properly, if I'm fast enough to click, we should be able to, wait, let me just make it a little slower. Then I can intercept it again. Yeah, right, now we intercepted it and it flies back. So basically, with this modal, we're kind of getting into territory where these kinds of more complex animation frameworks are useful. For the modal specifically, you don't necessarily need to use these. We also have an add-on called Ember Promise Modals, and we recently migrated that one away from Ember Animated to plain CSS transitions, because a modal generally is rendered very high in the DOM. So it doesn't suffer from this if statement situation. And we have complete control over when the modal itself is actually unrendered. And the benefit of that is that we don't have to force Ember Animated as a library upon users of the modal library. Because it's quite a hefty dependency, of course, relatively speaking at least. So this is, I hope the text is big enough. This is basically a breakdown of what happens under the hood with these kinds of animation frameworks. It's not all of it, but generally this is how it would work. The animation that you're seeing down here, we're going to get to that next. It's slightly different. In this case, we are actually moving an element from A to B, and they are two distinct elements. So it would be as if you have two if statements, like if A, render it here, if B, render it there. And basically what happens at time 0, so right as we start the animation, the framework would measure where A used to be, measure where B is now, calculate a transform to make B look like A, apply inline styles for the first frame, because that's how these frameworks have to work. And then we schedule the next frame with the request animation frame, and that's so that we sync with the browser frame rate. And then for every frame, basically, the middle section is going to happen. It's going to calculate based on the current timestamp where B should be. Where B should be. Apply inline styles for the frame again, and then schedule the next frame again with the request animation frame. And then when the animation is finished, it would remove the inline styles from the element. So generally this works well, and it's in most cases performant. But the browser now also supports something called the Web Animations API, which is very much like CSS animations, only it's controlled from JavaScript entirely. It provides a element.animate function, and you can pass keyframes to it and options. The simplest example, as we saw with the backdrop, would be opacity 0 to opacity 1, for example. Note that you don't have to supply any from or to in this case. You pass keyframes to this method combined with a duration, and the browser will interpolate that all on its own based on an easing you provided. The easings are relatively limited, similarly to the ones you get access to with the CSS animations, like linear, ease in, ease out, and like a Bezier curve, I think. The API also offers play-pause control, and there's like a finished promise to let you know when the animation is actually finished. And we wanted to see if we could use that in a more advanced or complex framework like Ember Animated. So that's why we started working together with some people from CardStack on an experiment. And basically this list is a bunch of stuff that we're throwing at the wall to see what sticks. It's not like necessarily what it's going to be, but we're trying to both simplify Ember Animated in the way it's used, because it's quite hard to use for people. It's like I have to look up stuff every time as well. And yeah, so conceptually the first thing, and that's actually a really nice thing in my opinion, is that we were able to simplify the primitives you need to just an animation context and a sprite modifier, as opposed to all of the animated if, animated each, animated whatnot, which makes it conceptually a lot simpler. So basically here we have the same modal example again. We wrap an animation context around it, rather than, what was it for the Ember Animated example? We have an animated if and another animated if, and yeah, our custom container element. So here we have this animation context with an animation definition, and our like modal is just inside of this if statement, and we apply these sprite modifiers onto the elements. And yeah, we give them an ID. We can also give them a role, but in this case, for the demo, it wasn't really needed. In practice, you would probably have a single backdrop and many modals, for example, or if you dare to nest modals, you could have backdrop modal. Yeah, so this looks exactly the same. That's not that exciting, but it's good that it looks the same, right? So yeah, the second part of this is that it utilizes the Web Animations API. And the big difference with Ember Animated is that because of that, we need to calculate all of the animations ahead of time, hopefully just in time, because we can't really necessarily guarantee that it will happen within like a frame, for example. And what we do in this experiment is push pre-calculated keyframes at 60 frames per second to the Web Animations API. And that basically allows us to, because of the limited default set of easings, by pushing 60 FPS, we can calculate more complex easings like spring animations. I think this one isn't on yet. Yeah, I'll get to this demo in a bit where we can see that. And the way we were able to remove like all of these animated if, animated each constructs is by hooking into Glimmer. And basically, just before Glimmer is going to render, inside of our animation context, we get notified and we can do all of the measurements that we need to do. Yeah, so this is basically the same kind of screen as we saw for Ember Animated, but the biggest difference is that all of the work is done ahead of time. So just before render, when we get notified by Glimmer that a render is going to happen, we pause in progress animations if there are any, so that we handle interruption properly as well. We measure where A is, and then just after render, the sprite modifier will let us know if there's any changes. We measure where B is, and and in this case B is an inserted sprite and A is a removed sprite. We then match B with A because they are the same, like we provided this ID modal in this case. And it will turn it internally into a kept sprite. So that, yeah, basically that's a way we can like tell the framework to handle these separate elements as one. We calculate all of the keyframes and then call element.animate with all of the info. And then basically we offload the entire animation for the runtime to the browser. So yeah, every frame we do nothing. There is no every frame here. It's completely asynchronous from the main thread. And then at the very end we do like a bunch of cleanup. So now let's look at this slightly more interesting demo where we have 4 ball sprites. I hope the code is big enough. But basically, as you can see, we've got 4 positions, A, B, C, and D. And we render a ball inside of one of them. We have a track property called ballGoWhere. And we just put a red div in there, which takes the shape of the parent. So if we like move it around, yeah, it moves around between all of these. And the animation for this is already set up, so we only really need to enable the sprite modifiers here. And I think this already has, oh, it's refreshing. Yeah, this has a slightly more exciting easing applied, like this is a spring physics animation. So this animation lasts roughly 2 seconds, I think. So we're basically calculating 120 frames ahead of time. But the animation is still very smooth. We can interrupt it. We can play with it. Yeah, so that's good. You can also do this with Ember Animated, except that in Ember Animated we can't really do these complex easings right now. And then the next thing basically that at least I was interested in is to see how this would perform with a lot of balls, a lot of parallel animations. So yeah, what I did last week was put 100 of the same demo in here and see if it worked. It wasn't quite as smooth as it is now. I had to do some performance optimizations because performance hadn't really been a core concern yet, because it seemed fast enough, and it's also quite unlikely that you will animate 100 things at the same time. But still, it's very useful because if you make like a performance profile with like the debugger here, if you do 100 at the same time, the things that take time are really going to stick out. So yeah, let's just show it. I don't know. Yeah, so it's not really smooth on Zoom, of course. But if you want to see it on my screen, you may. But this works quite well. Like the interruptions work as well. There's a very slight delay. I hope we can get that out eventually. But this is all very promising, I think. Yeah, and then another thing that's nice about using the Web Animations API compared to the like the more custom request animation frame based technology is that we actually have this animations tab here in our console. And if we do an animation, it's going to show up there. We can like see a recording of it. And if it allows me, yeah, you can also click it. There's like a timeline. So you can basically just, yeah, so this is a spring, so most of the movement happens at the beginning. But you can like very easily see if your animation is doing what you actually want it to. In this case, maybe the spring is a bit too soft because it takes quite a while to finish here at the end. Yeah, and you can also slow down your animations. So now we're basically running at 10% speed. Even though, like, this is a spring, so we're not, I can show some of the code, I think. Where is it? No, definitely not that. If someone is interested in this, do let me know. This is the low-level stuff. Oh yeah, it is here. Yeah. So basically, this is our transition function that we're passing it. And yeah, this is a function that I've abstracted called magic move, because this is basically something that you want to do quite often. It's to move things somewhere else. So that's hard stuff we can easily abstract away. So that would animate the position, the size, border radius, whatever. And we pass it a behavior in this case, which is a spring behavior. And there's some options to configure the spring. We could also use a linear behavior here to make it more similar to the modal demo, and we would need to pass a duration in that case. Let's see. Oh, yeah, of course. Thank you. Yeah. So, oh, yeah, it's still at 10% speed. That's not really. You can also change this in real time. So now we have a little more boring animation where it's linear. Yeah. Let me see. Yeah, so a final example, I guess, would be another demo that we have here called route transition. So this is a demo that consists of 3 routes. There's a parent route and 2 child routes. The parent route has the animation context in this case, where we define a transition, which is in this case also the magic move. It's somewhere in here. So please do not get scared by all of this. It's quite a lot. This has not been the focus yet so far. It's not going to be like this. But basically we're calculating here where we want to attach, like this is the animation that we're doing. We're doing a bunch of calculations based on the bounds of the elements to let our magic move know what it should do. So we have our animation context here, and there's 2 child routes with 2 link tos, and like their parent is decorated as a sprite in this case. I am missing one file. Yeah, here's the other one. So they are basically identical, except the color is different and the text is different. So yeah, so we're switching between routes here, and basically this tag allows us to do animations seamlessly between those routes. And again, this is something you can definitely also do with Ember Animated if you have the need already. So there's a demo that looks kind of cool here, which is also a bunch of models, I guess. But I would say this is probably like, it's a lot with this animation tag. It's also hard to share everything or even part of it. So I think questions would definitely be the most suitable form to continue from here.
That was awesome. There is one on Zoom here. So it's,
oh, nice.
Are we going to have a full-fledged replacement for Liquid Fire, the high-level stuff?
Yes, that is the idea. It's gonna be different from Liquid Fire, I think, in my eye at least, because Liquid Fire provides a bunch of abstractions on kind of a different level, where what we're aiming for with this new experiment is more declarative in a way. With Liquid Fire, it's a long time ago that I last used it, but with Liquid Fire, you had this transitions.js file, I think, where you said, I want to move this stuff. It was all in one big file, basically. And with this, like, let me see. I think this interruption demo is not a great one. Maybe the modal. So there is quite a lot going on here, but I can break it down a bit to show what we're kind of going for. So here you can see we're basically in the current version of the not so high level API. We are looking up our backdrop sprite and our modal sprite from the change set that we receive. Every sprite has a type, so there's inserted, removed, and kept. And basically we can break it down based on that. So for our inserted sprite of the backdrop sprite, we want to animate the opacity to 1 in this case, with a given behavior and a duration. You don't necessarily need to pass these, they're defaults as well. Whereas if we remove this backdrop sprite, there's a bunch of stuff. It's a removed sprite, so we need to move it somewhere, and currently you need to do that manually. You have to append it as an orphan to the context, for example. And then you set up an animation again where you animate to 0. And we do the same for our modal, basically, except the animation is different. Here it's like a position animation because we're moving it. So we have this inserted and this removed sprite type again. So we're basically breaking it down into a more declarative kind of way.
So I think you might have said something there that I don't know is like reading something into it, but you said you can do this in Ember Animated.
Yeah.
But this is Ember Animated, no? Like,
no.
is this going to be the future of Ember Animated, or is this something new? Right.
I think, yeah, so I didn't start the experiment originally. I continued it basically as of a few months, I think now. The description says it's a Spark for a next generation implementation of Ember Animated. I don't know, we don't have specific plans yet, like to make a version 2 of Ember Animated in the same repo. I don't know if it's going to be exactly the same. But in practice, I would probably want to use this one over Ember Animated, in its current form at least. That's also the goal. Like, the goal is to make it technically more modern, I would say, but also easier to use for end users, of which you could only kind of see half today, which is the template part, because the JavaScript part was certainly not very straightforward yet.
That was amazing.
Yeah.
I always feel like I understand animations whenever you do your talks.